And I will leave that to you. Before I leave you, however, let's take a look at our checkpoint. So what did I learn? The takeaways, you can fill this out now. What is unclear to you, you should also verbalize to yourself so that you know what questions to ask and where you need to get clarification. But I think the final checkpoint, we can use that to reiterate what we talked about. So we clearly can distinguish between 3 load cases now. We talked about self-weight, snow load, and wind loads. So we saw that the self-weight pretty much is acting along the rafter, the snow load acting along the footprint, and the wind load is acting along the rafter, but 100% perpendicular to it. I also understand the difference of the 3 load cases and how each of them act on the structure and what they effectively do to the structure. So now I can calculate for all these cases, the vertical and horizontal support reaction. That's always where I start. So that's according to a global coordinate system. And then I need to decompose them. So I hope after this lecture, I know that how I calculate the vertical and horizontal support reaction and break them down into the parallel and the perpendicular force components. Because without that, I cannot move on to actually draw the internal force functions, which now I can also create for roof structures. So with that said, we are ready for the homework. The actual homework problems are very minimal in this case, so don't get scared by all these scary drawings here. But really what's only required for you in the homework is problem A and B. And everything down here is optional. This is just something I added based on student feedback who wanted more practice before they go into the exam. But because this is the last homework before the exam, I don't want you to be overwhelmed with all the work, and I want to give you some freedom to studying what you want to study. If you want to study more on the non-orthogonal frames, then you have problems here that can help you to get a deeper understanding of the subject matter. But really, you only have to turn in these problems. So let's take a look at them. So the first one is fairly obvious based on what we've done in the lecture today. And that is that we have a roof structure with snow load on it. And that was essentially covered. So I believe this will be a good way for you to practice how to find the support reactions and then the functions and the internal forces along the slope members. So I don't think I have to tell you much more about this one. It becomes a little bit more interesting here on the right side because now we are combining a orthogonal frame corner with a non-orthogonal frame corner. You have the hinge here. So this part effectively acts like one part of the roof structure that we covered today, and this part acts like something we covered in our previous lecture. And so calculate your support reactions first and find your diagrams. Of course, to do that, I say that one last time, you need to identify the reference fiber. So I always put it on the inside, and that would look like this. But you are free to put it wherever you want to, as long as your diagrams match the system or the reference fiber. Now let's take a look at these optional problems. Again, these are not requested of you, but let's start with this one. I think this is an interesting problem because, again, it has a sloped member in it or a non-right-angled corner, but it also has a right-angled corner. And in this case, you actually have a very interesting case where the resultant force of this distributive force passes through this point. So you might be surprised how quickly you can solve this problem if you really take a look at it and see what's going on. In fact, in terms of what's going on, notice that this here is a non-loaded beam, if you want to call it that way, or a column. It's something in between a beam and a column, but it's not loaded. So that is something that actually prepares you for some topics that we cover after the exam, but more on that later. For now, just know there's a hinge here, and there's no load here. So that tells you something about the shear force and the bending moment diagram. And I let you play with that and practice that as an option. Now, this is a problem that has a certain difficulty level. Of course, difficulty is always questionable. If you know it, you know it, and then it might not be difficult to you. But my experience is that students perceive this type of problem as difficult, which is also why it's not really included in the homework set. It can take quite some time if you are just learning engineering mechanics. But let me tell you what makes the problem so interesting. So first of all, we have superimposed load case. We have self-weight here, and then we have snow load here on top of it. But we also have a non-right angled corner that has no hinge in it. So you have not seen this so far in this class. So we only had corners like here that had a hinge and then were not orthogonal. So what this means here is that the shear force and the normal force at the corner needs to be translated under the given angle. Whatever angle these values give to you, C and D produce a certain angle here to the horizontal. And so that leads to a transmission of the shear force and the normal force at that corner. That is technically beyond the purpose of this class, but if you really want to learn engineering mechanics, and for example, if you're a mechanical engineer or civil engineer, you definitely want to get a deep understanding of that, and I invite you to look into that. Again, this is optional, so challenge yourself if you like. If you're completely overwhelmed already, just don't do it. It's fine. This is just an opportunity that I added based on student feedback. Students said they wanted more of these types of problems, and they wanted something that really shows them the challenge as it could be in the real world. And so you could see something like this at a very difficult level in the real world. But that concludes the homework here. I wish you good luck studying that. Again, this is the last homework before the upcoming exam. So take this as an opportunity to practice and take this as an incentive to get you ready for your upcoming challenges when you really need to perform under time pressure. But of course, after all this homework, you should be really well prepared, and I hope that you will ace the upcoming exam. I have no doubt you can if you want to. So please want to, and I wish you good luck with that. I see you in the exam and in one of our following lectures. Until then, stay safe.